Hi, everybody. So if you remember from yesterday, we kind of left off about right here. We had written in a definition for the pH scale, and I just kind of talked through different ways you might say concentration, but the big takeaway is what these numbers mean, how we get them, and what would designate something as an acid or neutral or a base. But really catch the connection. I really like this table too because it lets you see it all right there that if we have a hydrogen concentration of 1 times 10 to the negative 14, well, that equates to a pH of 14. And this trend, you can just see it kind of work its way through. Right here would be neutral water. If we were to increase our concentrations of the hydrogen, so 1 times 10 to the negative 1 is a much bigger number than 1 times 10 to the negative 14, and that equates to a pH of 1. So the pH scale is really a logarithmic scale. There's a lot of equations on your reference sheet that deal with pH that we normally work through in this unit, but we are going to simplify this down to just having to use one equation and making sure that all the problems are going to be solved with this one equation. Okay, so here is a good example of what you're going to see. So if you're given this equation, pH equals the negative log of hydronium. Remember, it can look like this or H plus because a little proton's not going to float around by itself. But if we were to work through a problem like this, um, pardon me, our pH is equal to the negative log of 0.01 because I'm looking at this example right here. It says if the concentration of hydronium ions in a solution is 0.01 molar, what is the solution's pH? So now it's just a matter, I'm going to use a pretty simple calculator here. So I'm just going to take the log, and I could do the negative right away, but I don't need to. So the log of 0.01, it ends up being negative 2, but because it's a negative log, negative times negative equals positive. This becomes a pH of 2. Okay, so that H here is representing hydrogen concentration. Okay, so again, these are going to be pretty simple, easy to understand equations, I believe. The rest of this particular page just kind of gives you some highlights. So some common things, that we can look at. Those things that have a very, very low pH are going to be more acidic. Things that have a higher pH, less acidic, closer to the basic side of things. So if we look at tomato juice or coffee, milk in here, so getting close to the neutral pH of 7. Ammonia, we've talked about how that's a base, so it has a pH of 11, and then something really strong like sodium hydroxide would have a pH of 14. Okay, and again, this is just another picture. Just take some time to look at it, to process it, and see another way to represent pH. But for now, I'll go ahead and flip it over to the next page. And this is where we kind of ended with me wanting you to watch that other video yesterday, so today wouldn't get too long with the calculations. So I did different demos using indicator solutions. We'll define that in a second, but we could do this with a pH paper or an actual meter that would digitally tell us what the pH is. So these are just different ways that we could measure pH. So pH, what would happen in this case, I'm not really defining it, but just what you would see is the color change on the paper indicates a pH. So when one of my mares at my barn is about to have a baby, kind of an interesting thing, her milk will change in acidity about 24 hours before she'll drop her foal. And so I have pH paper on hand that if I'm starting to think, well, we're just getting pretty close to her actually having her baby, I can measure the pH of her milk, and it gives me a pretty good indication that she'll probably have her foal. So in farm term, we say drop. That doesn't mean she's literally going to drop her baby, but that's how we say in having her baby, so she's going to drop her foal within the next 24 hours. So pH can be really interesting for biological reasons and also just for general chemistry reasons. So pH meter kind of does a lot of the work for us. It's just a digital output of the pH reading. And then indicator solutions, that's what I had fun with in class. So with these cases and using this, the entire solution will change colors. This is my most favorite, depending on pH. Okay, so probably the one that gets used and abused the most is phenolphthalein. It's a favorite. The pink is just a really fun color, but I've used all of these. I didn't use either one of these yesterday. That Thymo blue is very close to the blue food coloring and what happens there as well, so it gives you kind of an indication. But these were some different indicators that were used way back at the beginning when we did that fun little changing water into wine, into milk, and everything else. We were using different pH indicators that would help that color change, make it a little more fun. So just to know that they're there, but the rest of this, we're just going to spend some time going through some of the math and quite frankly, marking out. You always love this part during COVID-19, marking out a decent amount of material that you're not going to be held accountable for. You're going to see all these equations on the reference sheet. Have at it if you want to have fun in interpreting them. Just like how we can find pH, we can also talk about pOH. But quite frankly, the only one that we're going to use is that top one. Okay. Likewise, this is leading us to not have to do as many of the problems here. So I'm going to have you mark out sulfuric acid as an example. And I'm also going to have you mark out these bottom two, phosphoric acid. Those are dipiotic and tripiotic acids, and we're not going to talk about those. We're going to talk about things that just release one hydrogen ion, and we're marking this one out because it's a base. All right. A few more changes to this table to have it work. I don't like my marking out. Let me fix this a little more. So you're not going to do this guy or this one. Or this one. Maybe that'll be a little easier. Okay, I'm going to have us change this column to pH because it's repetitive the way I have it right now to have it be concentration of hydronium. And we're going to change this to acid, base, or neutral to kind of mimic what you see on the bottom table there. Okay? All right, so if we're going from concentrations, it's practice using this equation right here. So this first time I'll plug in all the values. So we're taking the negative log of, here's our hydronium concentration. So 0.001. Okay, so when you do that, you plug it in here. Again, for me, I have to hit the log button first. I don't know if your fancy calculators have you do something else. But this is something that you need to have the skill in knowing how to do already. We get -3, but because it's the negative log, and you can easily plug in negative ahead of time, I just don't. Negative times the negative, positive. So we end up with a pH of 3. Okay, and just this is a practice in the scale. So a pH of 3 would indicate that it's an acid. I'm just going to put an A there for acid. So then if it's 0.1, we're doing the negative log of 0.1. And that would become a positive one, which is an acid. For this one right here, same thing, the negative log, but now 3.1 times 10 to the negative 8. Now here's one where you can't just go, it's going to be 8 because this 3.1 might mess us up. So you have to plug it in. If it was just 1 times 10 to the something, you don't even have to do the math, you can see. But in this particular case, once we plug it in, we get 7.5. Okay, so 7.5 is going to be basic. All right. Now, for this bottom table, there's no need. We're not going to teach you this year how to work in reverse. This is where, hey, if you want to have at it and have fun and try some of these equations, go for it. But we're going to keep it as simple as we need to, so you can get outside and jump around at 3 o'clock in the afternoon on Saturdays or whatever else it is you got to do. We don't need to be inside for the rest of May. So a pH of 7, this is again, we're just going to let me practice with remembering the scale. pH of 1 is going to be acidic, 1.5 acidic, 3.3 acidic, and then this last one, just again reading of how it would be basic. Okay, so I'm taking you to that point in the guided notes. Need to spend a little time, and Miss Merkus was awesome. I was gone those last 2 days before, and I really was gone now, I could say, because we had family members that were showing the symptoms of corona, and so we knew that the right thing to do is to stay home and not potentially infect somebody else. And we still don't know if they had it because they weren't doing true testing at that point. It was just, if you have the symptoms, we're going to assume you have it, stay home. So we're ready for that antibody test ourselves. So Ms. Merkus was unbelievable in getting all of this stuff together for you guys before you left, or very closely to when you left. With that, it's hard to predict 4 weeks ago what we would have actually taught right now. So we know it's kind of a pain to make all these corrections, but we hope that we've prepared you pretty well with handouts and materials from now until the end of the year. You're not having to print new things up unless you just chose not to come in, which is fine too. So I'm now looking at your activity, your packet, your acid-base packet on page 5, and you should be getting excited. You're seeing all these things we're crossing out, which is true. So you're not going to do table 28 at all. You get to cross out all of 28. Okay, for number 29, excuse this little purple mark right here. It really, and let me see if I can magnify this just a little bit more, see if that can help you with everything. I don't know why I wrote that mark there. You don't need to worry about that. But what you can do is you're going to mark out what you see that I did. So mark out this, what is hydroxide ion concentration. Okay, and then it's going to read just like this. So we're going to be asked basically, is it acid, base, or neutral, and then what is its pH. For number 30, instead of you finding the hydroxide, find the hydronium concentration, decide if it's acid, base, or neutral. For 31, there is no change. How about that? 32 and 33, mark those out. No need to do them. 34 is good the way it is. And then if you can flip it over, there's a few more you're going to mark out. Mark out 35, 36, 37, we keep just as it is, and then mark out 38. Okay, so it just got easier, huh? I'll post the answers right in with the assignment for today, so you'll see the answer key there. Mrs. Merkus is going to talk through titration, which is really the last concept of this unit. We'll be going into a required lab at the beginning of the week next week, but we're going to be testing on acid, bases, and salts pretty soon. I think the plan is to do it at the end of the week next week, so next Friday is whenever we'll be wrapping up this portion. Okay, hope everybody's doing well. Look for those answers, and we'll see you in Google Meets if you need to talk. Take care.